Hey guys, it's Elton here to help you out with your homework. Tonight's homework is on the zero product property rule. Remember, it's called the zero product property rule because when you multiply anything by zero, you get zero. For example, let's just pretend that this whole term was zero. It doesn't really matter what this ends up being. Let's just say whatever you plug in here to get zero, you get 7 over here. Well, you know that 0 times 7 is still 0, and therefore whatever makes this piece 0 is a solution to this quadratic equation. And it's true the other way around for the other quantity there as well. So for this one, we can just inspect what minus 5 equals 0. Well, the answer to that would be 5. Same thing here. Just to make it a little more interesting, let's pretend this said 2x. It's not as easy to see what times 2 plus 6 equals 0. So one thing you can do is actually write an equation. Set that whole quantity equal to 0 to figure out what that needs to be. It's just a two-step equation, but breaking it down this way might make it easier for some of you. You get 2x equals negative 6. Half that, you get negative 3. So my two solutions to this, if that was 2, would be x equals 5, x equals negative 3. Now, the reason some of you may be here is you might be confused. Well, what happens if there's, like a 2x in front? Well, I would just ask you, this is another quantity technically. What would make this piece equal to 0? That's my question for you. So in this case, we're actually going to get 1, 2, 3 solutions, one for each quantity. So this actually isn't even a quadratic equation. This is actually a cubic equation. Kind of tricky, but not too bad. Let's take a look at one that's not factored for us. Just to review factoring, as long as there's no number in front, you can always ask yourself factors of the last term that do this operation to the middle term. So factors of 24 that add to 11, well, let's write down some factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Think, do any of these pairs add to 11? Yes, Mr. Elting, you should say that 3 and 8 do. So x and 3, x and 8. Our signs are easy in this problem. They should all be positive, which interestingly enough tells us that the roots, the solutions to this, are just the inverse of that, negative 3 and negative 8. Hopefully that helps you get through most of these. There are some special case factoring problems. Just do your best on them. See if you can't figure it out. And I'll see you tomorrow.